let's do a couple of problems, probability problems, basic probability problems. So a baseball player got, this is up right up my alley. Baseball player got a hit 19 times out of 64 times at bat. So his sample space is 64 times at bat. And outcome, the number of favorable outcomes, was 19. So probability got a hit would be equal to 19 divided by 64. I don't think I can simplify that fraction. But let's find out what it is as a decimal. So 19 divided by 64. Oh, let's call it that's a 297. That is a 0.297 probability, which, by the way, is a pretty good batting average. But now we're extending the problem a little bit further. It says, well, that's great. He got to hit 19 out of 64 times at bat, but what if he comes to bat 200 times in a season? Well, how many hits is he likely to get? Well, let's look at this just a little bit more carefully. This was 19 hits. That was our favorable outcome out of 64 times at bat. So we know we have a ratio of 19 to 64, but instead, we're going to not have 64 at bats, we're going to have 200 at bats. To keep the same ratio, what is going to be our number of hits? Well, we have this really interesting proportion going on right here. So I can cross multiply because I have an equal sign there. So I can go 64x is equal to 19 times 200. I don't know 19 times 200. 19 times 200. So I get 64x is equal to 3,800. I divide both sides by 64, and I find out that x is equal to, divided by 64, well, 59.375. Now, so this would be the number of hits. That would be the number of favorable outcomes. But I want you to think about this for a second. It's really impossible to get 0.375 hits. You're either getting a hit or you're not getting a hit. So in this particular problem, in order for him to bat at least 0.297, you would probably round this up and you would say x is equal to approximately 60 hits. There's a lesson in probability and how we can then make predictions with it. As well as a little bit of thought that has to go into the fact that you can't have 0.375 hits. Let's try an additional problem. So a music collection includes 10 rock CDs. I'm going to write this down as I go along. So I have 10 rock, 8 country. I hope you all know what CDs are. You know, it's kind of old school. They could say record albums or vinyl, but you certainly wouldn't know that. 5 classical. And again, maybe you would. I think that's coming back. 5 classical and 7 hip hop. Those are all the CDs that I have in my collection. And I want to know if I get one CD randomly, it says a CD randomly selected, what is the probability that it is a classical CD? So I'm looking for P classical. So my total number of favorable outcomes is 5. 5 favorable outcomes. What is my sample space? The total number of CDs. Well, I have 18 plus 5 is 23. Oh, it looks like I have 30 CDs. Let's just make sure I got that right. Yeah, I paused it. So it's 5 out of 30. Well, I can simplify that into 1 out of 6, and I know from the problems that we did a little while ago that that is a 0.167. So P classical is a probability of 0.167. Now it's asking, well, what is the probability that a CD randomly selected is not classical? Well, I have to use my complement power now. So I'm going to go 1 minus P classical. So that would be 1 minus 0.167. And that is equal to, well, let's just do it over here to make sure I don't make a decimal error. 1 minus 0.167, 0.833. 0.833. That is P not classical. This is skipping just a little bit ahead, but I think it'll give you a nice little introduction to what's coming next. I know I have 30 in my sample set, so my 10 rock would be a 10 over 30, 1 over 3, that would be a 0.33 probability. My 8 country would be 8 divided by 30, and that's a 0.27 probability. My 7 hip hop would be 7 divided by 30, and that's a 0.23. And let's just do something, and let's add up, well, all the ones that are not classical. Well, I have 0.33 plus 0.27 plus 0.23. And I find out, well, what do you know? It's a 0.83. So it's the same as that if I carried it out to 3 decimal points. And that's true, because the not classical CDs are the hip hop, the country, and the rock.